This slide outlines two critical architectural patterns, the repository and unit of work, that are essential for maintainable and testable enterprise applications, specifically for the data abstraction. The repository pattern, its primary focus is to decouple the business logic from how the data is stored, and that implies that the business rules don't care how the data is accessed or stored. Say, if you are using SQL Server via EF Core, or NoSQL database via Dapper, or the REST API calls. This pattern enforces single responsibility for data access, and the iRepository interface only uses data access, and it does not contain any business logic. Business services should interact with an abstract iRepository interface, and it doesn't directly invoke a concrete DB context. To quote a real world example, say we have a user service that is requesting for the user data. This service solely depends on the iRepository interface. Um, it doesn't know if the data comes from the entity framework or a Dapper or a stored procedure. The user repository implementation could be using anything from a simple SQL query or a stored procedure or cached API calls. So the service just knows that the data will be returned. And this helps in creating mockable and testable applications. The unit of work complements the repository pattern by managing a group of operations using atomic transactions. So this ensures consistency across all the multiple repository operations. This slide describes the abstract design pattern and how it is used to decouple the client application from the database technologies that it uses. The abstract factory defines a set of methods for creating different types of related products. In this example, we talk about uh, IDB provider factory interface as the abstract factory here, with abstract products like create connection, create command, and so on. The concrete factories implement this interface, and they provide each of them provide a specific implementation. Say the SQL Server factory is returning an SQL connection and returning an SQL command in turn. The client code interacts with the abstract factory and abstract product interfaces without being coupled to these concrete classes. So the service is configured and injected using dependency injection to receive the correct factory at runtime. This is crucial for multi-tenant environments or the migration strategies. A single application can be deployed and we can switch the data backends by simply changing which concrete factory is injected into the service container in the startup. This enables easy switching between the product families or the database technologies in this example at runtime by simply instantiating a different concrete factory. The strategy pattern defines a family of interchangeable algorithms, and the clients can choose the behavior at runtime. And the core value is enforcing the open close principle. So it makes the code closed for modification, and it reduces the risk of introducing bugs and redeploying core classes by using extension. Teams can independently develop and deploy new strategies, increasing the development velocities. An example to quote would be a different strategies for generating different report formats. For example, using concrete report generator